Hi and welcome to this video in the series on right-angled triangles. This video dealing with finding an unknown angle. So we're going to go through a very similar process to what we have done previously, in that we are going to name the sides of the triangles, figure out which of the ratios we're going to use, arrange the equation so that what we're looking for or our unknown is the subject of the equation, whack that all into a calculator, and then come up with an answer to whatever the specificity is of the question. Okay, so essentially what we're going to do first, just change my color, is I'm going to take this first example and I'm going to name the sides of my triangle. So we're looking for theta now, we're looking for the unknown angle. We have previously done unknown sides. Now we're going to do unknown angles. So here we go, we're going to go H for hypotenuse, since this is our little right angle symbol here, making sure that they're opposite to each other. This is our angle here, so our unknown angle is right there, which means that this side here is the adjacent side because it is right next to the angle, and this side over here is the opposite side because that is opposite to the angle. And we're going to do the exact same thing as we've done before in setting up what we're doing. Okay, so for this one we have the opposite side and the hypotenuse, so we're going to use the sine ratio. So sine theta equals opposite over hypotenuse, or the SO part of SOHCAHTOA. Alright, we're going to plug in now exactly what we need. So we don't know theta yet, so sine theta stays the same. Our opposite side is 16 and our hypotenuse is 24. So there's the bits that we need to get in. Now as you can see, we need to rearrange our equation a little bit. We need to get theta on its own. Okay, we want to get theta on its own. So essentially what we're going to do is we're going to take theta and we're going to do the reverse of what we've previously done. So previously we would have gone sine whatever, sine of the angle, it would have been either hypotenuse multiplied by the sine of theta, of whatever theta is, things like that. We're going to use the reverse, which is sine to the minus 1. Okay, sine to the minus 1, you'll be able to find it on your calculator using shift sine, or if you're using cosine, it'll be shift cos. If you're using tangent, shift tan. Easy to find on your calculator using the shift key. And then we just add the 16 and the 24 in like so. This is the bit we get to plug into our calculator. Once we've plugged this into our calculator, we should get this really long, funky decimal. But we're actually being asked to do this to the nearest degree, which is otherwise known as the nearest, oops, helps if I learn to spell. Nearest whole number. Okay, we want the nearest whole number for this one. So as per usual, we'll do our rounding. We can see there that we're rounding at the decimal point. Our next number along is an 8. That's closer to the one above than it is the one below. So theta is going to be approximately equal to 42 degrees. So that one goes up by 1 because that's where it's closest. Alright, so this is using the sine ratio and just whole number or nearest degree for this particular problem. Let's have a look at the second example. Same thing again, we need to label our sides. Here's our H, our A and our O. You can see there this time because of where that relevant angle is, which is here. That's the one that we're using, so we're going to be hitting up the cosine rule this time because we have the adjacent side and the hypotenuse, which is the car part of SOHCAHTOA. So I'm going to start with cos theta equals A over H this time. So sine obviously being opposite, cosine being the adjacent. Do exactly the same thing as I did before. Alright, cos theta stays the same because we don't know theta, but then I'm going to pop 4.2 over 6.8. Same deal as before, I want the reverse action of the ratios. So cos equal, or theta rather, equals cos to the minus 1. Again, just shift cos in your calculator. Shift cos in your calculator does the job. And it's going to be 4.2 over 6.8. Whack that into your calculator using all the correct keys, hopefully. So it's just shift cos 4.2 over 6.8 using your fraction key. Close off your brackets. And you should get 51.8554869. But for this one, it's a little bit different. We want to the nearest minute. Now, rounding with minutes is a little bit different. So the first thing that we need to do is use that degrees, minutes, seconds button. The degrees, minutes, seconds button. So it'll either be DMS on your calculator, or it'll be the degrees with an apostrophe and then the quotation mark. So they're the two keys that we're looking for. Once we've hit that, you should get 51 degrees, 51 minutes, and 19.75 seconds. Now, what we're going to be doing in here is we are going to be looking for halfway. Alright, so look for halfway, which is 30 for this one. So we're looking for what's less than 30 or more than 30. This one here is what we're looking for nearest minute. We need to determine if this one's more than halfway or less than halfway. So if halfway is 30, this one's less than halfway, so it all stays the same. So we're going to have theta is approximately equal to 51 degrees, 51 minutes. That's all there is to doing this particular type of problem. These are fairly simple ones. Hopefully this video has given you a little bit of help. Good luck with all your questions, and thanks for watching.